Hi class, this is Juliana here. We're going through 16.3. These are proofs. We love proofs, don't we? Proofs are the best. I am going to just have one lesson. I'm going to fill the 15 minutes with just doing numbers 1 and 2 and then 2 on the last page. So we'll be doing 4 proofs today. Now, the reason we're not really going into them wholeheartedly is because we've already done proofs several times. We know the proof process. So we're just going to be using those congruency theorems, the side, angle, side, 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 angle, side, angle, 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 side, and HL theorems in order to prove triangles are congruent. They're very simple. In fact, a lot of times teachers will start with the triangle congruency proofs because they're the simplest of all the proofs. All you have to do is mark the given on the picture that you have. So mark it, analyze it, figure out which of the 5 theorems it is and which sides and angles are congruent. Write out the side, write out to the side which of the theorems it is after you've marked congruent angles and sides. And then all you have to do is state all of the only the 3 shortcut sides and angles, whichever mix it is of them. You only have to state each one of those. And once you have each one of the 3 sides and angles stated, then you can state the triangles are congruent. And you'll see that most of these say, prove that the triangles are congruent. All right? And that's all we're going to be doing. It's pretty simple. By the way, this section, 16.3 or 16.4, I can't remember which one it is. It's this right here. So it's the homework for 16.4. Does have labels printed out, those little sticky labels that we've used before in proofs, that you can come to the school on the front table and grab a little label sheet and stick them on that way if you don't want to write them out. I don't know, some people might want to do it that way, but that's fine. All right, so number 1, we read the given and mark. So PQ is congruent to ST. For that, we mark PQ and ST and just give it a single dash so that we know those 2 are the sides that are congruent. And then QR is congruent to TR, so QR and TR are congruent. And we know those 2 are congruent, but we don't know that they're congruent to the other ones, so we have to distinguish them separately, that they are congruent with 2 dashes. To each other. And then lastly, we know that R is the midpoint of PS. Now, if R is the midpoint of PS, then we know, because we've been doing proofs for a while, that the 2 segments that R breaks PS into are congruent. So we have those 3 congruent sides. Knowing me, I like to make it a few little color coordinations here. So I like to mark the sides that are congruent. But after you've marked this, after looking at that and marking, you know that this is going to be a congruent set of triangles by side, 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 right? Side, side, side. Very simple. So we know side, side, side as we go around, right? So that's our first 2 steps of doing a proof. First, we mark, and then we determine which of the 5 congruency proofs theorems that we're going to use in order to prove these are congruent. And then we just have to make sure that we state each of the 3 corresponding sides are congruent to each other, and we know for sure the triangles are congruent by side, 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 and that's our final step. So we know PQ is congruent to ST because it's given. We know QR is congruent to TR because it's given. And we know R is the midpoint of PS because it's given. So all that is given, and we've got the blue set and the purple set of congruent sides, don't we? So we have the S and the S of the side, side, side already stated in the givens. So next, because R is the midpoint of PS, we know that PR is congruent to SR. So that's our 3rd side. And we know that by definition of midpoint. All right, very simple. I have a side, and a side, all done. And by side, 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 triangle PQR is congruent to triangle STR. All right, and we're done. I don't know if you think that same thing that I do, but man, those are sure simple compared to the last ones we were doing, right? I'm going to do number 2, and then I'm going to leave this page and go to the last page. So when it says SQ, that's this side here, bisects angle RQT and angle RST. So this is a bisector of both angles on the ends. If you recall, when we did bisectors before, what we did is we knew that this and this angle are congruent, and these two angles are congruent, right? You know that for sure. Because QS bisects angle RQT, then it will break that angle into two equal angles, equal in measure. And then if it's bisecting RST also, then it breaks this into two congruent angles. So we got those two congruent angles. And then we know that this middle side is congruent to itself by the reflexive property because it is QS as one side of the triangle here, and QS is the side of the triangle on the bottom. So QS is the side in both triangles, so it will be congruent to itself, and we always use the reflexive property for that. Because of that, and because we have it marked, now we can see as we go along, we have an angle, a side, and an angle. All right. So now we know by which theorem we need to prove, and now we know that we need to make sure we state these angles are congruent to each other, this side's congruent to itself, and this angle is congruent to itself, or congruent to the other angle. All right, so that's given. We know SQ bisects angle RQT and angle RST because it's given. We know that angle RQS is congruent to angle TQS. All right, those two angles. So RQS is this angle and TQS is this angle. These two are congruent because of this definition of bisects. We know that the two will be congruent. So definition of bisects. All right. And then RSQ is congruent to TSQ. These two are congruent by same thing, definition of bisects. All right, so by definition of bisector, the two angles are congruent. Then the last thing, we got an angle and an angle, the two angles. Now this included side, the side between the two angles, is QS, and it's congruent to itself by the reflexive property of congruence. And because of the angle, side, angle, we've stated each of the two angles are congruent in the side, and therefore we know the two triangles are congruent by angle, side, angle. All right? So that's how you would do these types of proofs, and you would do everything the same way. The next one, these are right angles, so you would mark these as right angles. ML is congruent to MN. Those are congruent sides by the given. We also know this side is a reflexive side, and we have a right angle, a hypotenuse, and a leg. So this one's going to be HL, but I'm going to let you go through that one. But just wanted to point out that's what we're going to do every time is we're just going to just mark and analyze and then start stating everything's congruent. Now, those are two where the reasons were given, where statements were given to you and you were asked to come up with the reasons. On the last three, the given is only, the only thing given to you is the given. So we're going to have to do them all. Now, I am going to actually do 7 and 8 with you the remaining time. Hopefully I'll have enough time to do the last two. And then I'm going to let you guys try the rest. And then on Thursday when we get together, you can ask any questions that you have on proofs. All right, so given that AB is congruent to CD, we can mark that. There's AB, and that's CD right there. Make sure we get the right sides. So these two sides are congruent to each other. I'm just going to actually color the code those with pink. And then AB is also parallel to CD. Now, if those two are parallel, you can draw a little arrow on them, then that gives us a bit of information about angles. Always the parallel gives us angle information. So if these two lines are parallel, this becomes a transversal, and this angle will be congruent because they are corresponding angles, right? That's what AB is parallel to CD gives us, is corresponding congruent angles. And then if D is the midpoint of BE, BE is down here, if D is the midpoint, then BD has to be congruent to ED or DE. BD will be congruent to DE. It's basically one triangle slid over, isn't it? But we have going around, we have side, angle, side. Side, angle, side, an included angle between two sides that are congruent. So that's what we'll use as our theorem to prove the two triangles are congruent, which is what we're asked to prove every time. Triangle ABD is congruent to triangle CDE. All right, so we're going to state the given, and each of them are going to be used in our proof. So let's start with this, the parallel lines. AB is parallel to CD. All right, that's given. Now, what did we get from that? We got that angle ABD is congruent to angle CDE, didn't we? So angle ABD is congruent to angle CDE, and that's by definition. No, wait, not definition, sorry. It's by the corresponding angles theorem. Corresponding angles theorem, okay? And then we also know that D is the midpoint of BE. And that was given. And from that, D being the midpoint of BE, we know that BD is congruent to DE. So BD is congruent to DE. And that's by definition of midpoint. All right. And then we also have, so that gives us the two angles are congruent, the two sides are congruent. Now we need to just state the AB is congruent to CD, which is given, which is nice. And we have a side, and an angle. So we have everything set up that we needed to prove. So therefore, triangle ABD is indeed congruent to triangle CDE by side, angle, side. All right, I have about 3 minutes left to go through the next one. So I'll try to do that quickly. If E is the midpoint of both AB and CD, E is the midpoint. I'm going to mark them so you can see them. If it's the midpoint of AB, then this side is congruent to this side. If it's the midpoint of CD, E is, then this side is congruent to this side. And they're corresponding sides of the triangle. Now, that's all we're given. But even though if it's not given, we still know that these two angles are vertical angles, and therefore they have to be congruent by virtue of the fact that they're vertical. So what we see here is side, angle, side as we move along. That's what we're going to prove. So if E is the midpoint of AB and CD, that's given. Then from that, we got that AE is congruent to BE. I like to find the way that it's written up here, AE and BE, that's in that order, and that just kind of helps me know for sure that I have the right order set up. And then E being the midpoint of CD is CE, so CE will be congruent to DE. All right, CE and DE are congruent, and that's because these two are actually just by definition of midpoint. And I like to do them both at the same time, but we'll just write it out. It gives us a line to do it, so we'll write it out. And then we have our two sides by definition of midpoint. Now we just need the vertical angles. So angle AEC will be congruent to angle. Now I started here on the end of the single dash, so I need to start here on the end of the single dash, BED, angle bed. All right, and that's going to be because of the vertical angles theorem. And I have a side, an angle, and a side that I've stated specifically in my proof that they are congruent to each other. So now I can state that triangle AEC is congruent to triangle BED by side, angle, side. All right, now this will be just one video for section 16.3, and I'll post it, and then we'll post 16.4 next. But those are my two, those are the section 16.3, everything you need to know. All right, good luck with that. And by the way, the homework is just finishing those of the 9 proofs I did not do. We did 4 of them. You guys have about 4 or 5 left to do. Good luck.